Hello everyone. Today we are going to solve another Bayes theorem problem. This is one of the popular problem that's often asked in interviews. Let's read the problem. So there are three friends in Seattle and they told you that it is raining, and each of the friend has a probability of 1/3 of lying. And what is the probability that it is raining in Seattle? So I'll give you a couple of minutes to read this statement and see if you can solve. As usual, I'll try to actually start with the Bayes theorem and then Markov chain rule. And then once that is done, I'll go to this review this problem and then solve this problem. So if you're already familiar with Bayes theorem and Markov chain rule, you can skip the next 2 minutes and then join back when I'm trying to solve this problem. Okay, let's review Bayes theorem. So Bayes theorem essentially, is probability of A given B can be expressed as probability B given A times probability of A by probability of B. So this term is a prior probability, this is a likelihood, and this is a marginal probability. So this is the Bayes theorem, and the Markov chain rule is you can compute probability of A intersection B as probability of A given B times probability of B, or it can be expressed as probability of B given A times probability of A. So from this one you can simply derive this Bayes theorem by putting this denominator down. So let's look at a little bit extension of this Markov chain rule. It's a probability of A, B, C, D, which can be expressed as probability of A given B, C, D times probability of B given C, D times probability of C given D times probability of D. Right. So in this we assume that there is actually no order here. So we could have simply written the same equation as probability of A, C, D times probability of A given C, D times probability of C given D times probability of D. So this Markov chain as well as this Bayes theorem, they're very useful in solving these Bayesian problems. So I hope you are familiar with these two equations. So let's look at the problem again and then try to solve it. So the problem says there are three friends in Seattle who told you it's raining, and each of the friend has a probability of 1/3 of lying, and then you're asked the question, what is the probability that it is raining in Seattle? Okay, let's try to solve this problem. Usually I'll try to solve it a naive way. So the naive way would be, okay, what is each friend has a probability of saying lying, let's say is equal to 1/3, or probability of not lying or saying yes it's raining is you will say something like 2/3, or saying the truth, right? So you're 2/3, and then each of the friends, they are independent events, so you say 2/3 times 2/3 times 2/3. So you could say 8 by 27 as a probability that it is raining. I would say this is a not accurate solution. I mean, some people can agree with it, but there is a better way of solving, and we will look into that. So why I'm saying this one is not accurate? So what we are answering here is actually probability of your friends are saying truth. Actually saying truth when it's raining is 8 by 27. But the question we are asking, probability that it is raining in Seattle. Yeah, you may ask, if it is raining in Seattle and they are saying the truth, isn't it the same thing? No, actually, in fact, this is not the same things, because I'll give an example. Let's say in Seattle it rains all 365 days, and you ask him, is it raining? And then in whatever the probability of them saying the truth, it will be actually the probability that it rains in Seattle is 1, right? it's raining whether or not your friends are saying the truth. Like, so, and if it is never rains in Seattle, even though the probability is 8 by 27, the probability that it rains, given that your friends are saying it's raining, is actually 0. It's not 8 by 27. So these two questions are different, and our equation, our solution fails in these two scenarios. So why weren't we able to solve this one? I think we didn't know what is the probability of raining. We didn't know whether it rains 365 days or whether it rains 0 times, right? So this is where we make an assumption that probability that it rains in Seattle, let's say we put this as PR. So we try to make this assumption and try to solve it, and then we can plug it in whatever the value. If somebody says the probability it rains is 0.7, we plug it in the value and we get the answer. Or if somebody says it's 0, then we can plug it in and get the answer, and so on. Okay, let's given the way we are trying to solve this one, let's look at the problem again. 3 friends in Seattle said it's raining, and each has the probability of 1/3 of lying, and then what is the probability of it's raining in Seattle. So let's solve this one. So it's a bit, so what is given to us, probability that the friends are saying it's raining. Let's say they are saying it's yes raining. Given it's raining is actually 2/3 times 2/3 times 2/3. It's 8 by 27, which we looked at before. And then what is also given is probability that they say yes it's raining, it's raining, given it's not raining, right, which means they are lying, is equal to 1/3 times 1/3 times 1/3 is equal to actually 1 by 27. Probability of rain in Seattle is we already made a notation of PR. So now the question is, what is the probability that it's raining given all of your friends said it's raining, right? So this is what is the problem asking. So it's simply we apply Bayes theorem. Probability of everybody is saying it's raining times probability of raining by probability of everybody is saying yes. Oh, yeah. So we know this one from this equation. We know this one from this equation, but we don't know this particular one. So we need to derive that one, and then that can be simply written as probability of y. Let me write this down by. So each of the friend is saying it's raining, or each person is saying yes. This is actually, we know, given it's not raining and probability of not raining. So we know this term. With this term is essentially probability of not raining is 1 minus PR. So we substitute those values and we'll get the answer. So in this case it's 8 by 27 PR by 8 by 27 PR plus it's 1 by 27 PR 1 minus PR, right? So it's 8. So you can actually 8 PR by 8 PR minus PR, so it's actually 7 PR plus 1. So this is our final equation. So the question is this one: what is the probability that it's raining, that your friends are saying it's raining, all 3 of them, is equal to 8 PR by 7 PR plus 1. So let's substitute our 2 extreme cases, which is when PR is equal to 1, which means it's raining all the time, right? So you substitute here, you get probability that it's raining given your friends are saying yes is equal to, actually in fact, 8 by 8 is equal to 1. When PR equals to 0, then it's actually 8 times 0 by 0 plus 1 is equal to 0. When let's say it's raining 50% of the time, so the probability that it rains is 0.5. You can substitute it here is 8 by 2 by 7 by 2 plus 1 is equal to 8 by 9. In fact, this is what you have derived in the beginning, but then we which means that we made the assumption that it rains 50% of the time. Okay, I think that's how we solve the problem, and the generic solution is going to be 8 PR by 7 PR plus 1. If you make the assumption that it's raining 50% of the time, you get an answer 8 by 9. That's why I said it's probably true but not very accurate. Okay, that's all for now. We will see for the next problem.